Okay, so this was part of the homework, page 12, number 21. Looking at this, remember, BandMass still applies. So right here, let's do the bracket first. Inside the bracket, what is my base? What's my base number? Claire? -2. So do I need brackets around that -2? Yes, because that's part of my base. So negative, you see brackets? You make sure you do put brackets. Since I'm multiplying, I'm gonna add my exponent. So 3 plus the 5 gives me the 8. Don't forget, there's another exponent on the outside. So put that extra bracket there with the 3. So now exponent raised to another exponent. What do we do again? Yep, Vincent? Multiply it. So 3 times 4 gives you 24. So I could simplify this one further. Well, remember, if I have negative base with an even exponent, what is my answer going to be? Positive, right? So technically, I could simplify this to just 2 to the 24. But if you just leave it as this, it's perfectly fine. I'll take this as well. I just wanted to show you guys, if it's a negative base with an even exponent, it will always give you a positive answer. Okay. Next one I wanted to go over is page 13, number 31. One of the harder questions from yesterday's homework. Okay, 4 to the 4 times 8 to the 3. What's wrong with this question? Umi? The bases are different. So I know there's a connection between 4 and 8. 4 times 2 is 8. But is that what we're looking for? 4 times 2 equals 8? No, remember, what is this chapter based on? It's based on exponents. So you need the same base with the exponent. So what's the connection between 4 and 8? Do they have a common base? 2, right? That's right. So instead of 4, can I replace it with something base 2? Uvi? 2 to the power 2. So I'm just replacing the 4 with 2 to the power of 2. I still have my exponent 4 right here, times, and then what about 8? What can I rewrite 8 as? Yep, Claire? 2 cubed. Okay, so you see what I'm doing right here is I'm just replacing that. And then the exponent on the outside is still outside. Okay, now I can do what the exponent rules. As Vincent said, when you have an exponent raised to another exponent, you multiply. So this is 2 to the 8. And then here, this is 2 to the 9. Okay? And then now that I'm multiplying, I add my exponent. So you get the final answer 2 to the 7t. Okay? Okay, just as a recap of what we did on, is it Monday? Yeah. No, Tuesday. Tuesday with scientific notations. Okay. If I do this on the calculator, like, so let's say this is writing it as a single power. If I want you to evaluate, I'm going to punch it into the calculator. Right, so on the calculator, 2, and then exponent. Remember, this is your exponent button, not this one. So 2 to the exponent 17, and I get this as my answer. All right, 131072. Right? This is to evaluate. And as a recap of what we did, how do I write this in scientific notation? Scientific notation. How do I rewrite this number in scientific notation, Derek?
1.31072 times 10 to the power of
5, yes. Good. Everybody was telling you it's 5. Good. You guys counted correctly. And then this would be in scientific, uh, I can't spell. Scientific. What am I spelling? I wanted to write short form. Here, I'll just write short form. Scientific notation. Okay. So, again. Okay, so back to the math. The So today's lesson is very similar. That's why I was telling you guys to make sure you finish the homework so that this makes much more sense to you. So let's take a look at example 1 here. When you have right here two numbers with different base, okay, I can't combine them, but I could still apply my exponent to everything inside the bracket. So this becomes 5 to the 4 times 6 to the 4. Now, will it give me the same answer if I do 30 to the power of 4? All right, what do you guys think? Is this the same as 30 to the power of 4? Yeah. It is, yeah. Because if you just do BEDMAS brackets, 5 times 6, 30. 30 to the power of 4, you will still get the same answer. Just like on the test, you know how that tire question, when you buy 4 sets of tires, some of you were asking me, do I do the discount first or do I times it by 4 first? It's the same answer. You'll get the same. Okay, so same idea right here. This is not really simplifying. It's just you can simplify it like this or you can simplify it like this. This is just telling you that if you have an exponent outside a bracket, it applies to everything inside. Yeah. So same thing right here. Even if you have an exponent, so you would do the same thing. So 2 cubed raised to the power of 5 times 4 raised to the power of 5. Okay. This one, in fact, can I simplify this even further? Hannah? Hannah? Can I? Yeah, because the 2 and the 4, I can also, just like the question that we just did 5 minutes ago, I can rewrite this as 2 squared. Okay, so for these type of questions, you have to recognize the base. If you can force the base to be the same, then you would you keep going. So here I will have 2 to the power of 15 times 2 to the power of 10. So what's my final answer? What does all this simplify to? Vincent? That's it. Okay. So again, this is tying together with what we learned yesterday. Same thing with these ones right here as a fraction. We didn't do a fraction question together, so let's do one. So your exponent applies to the numerator and to the denominator. So here you have 4 to the 2 square, which gives you 4 to the 10, and the bottom 5 to the 5. Right? Even though this one doesn't have an exponent, because it's inside the bracket, you apply it as well. So you have this. Okay. Can I simplify this any further? No. All right, because my base here is 4, my base here is 5. There's nothing common. I leave it like this. I cannot suddenly subtract the exponents. Okay, so I cannot simplify it to something like this. I've seen people do that. Okay. Let's say, okay, this one right here. This is a tricky one. Okay. So what's my base right here? So again, I'm applying my exponent to both of these. So what's my base number right here? -2. So because my base is -2, should I put it in bracket? Yes. Okay. Unless you say your base is just 2, then you don't need bracket. But if it's -2, you need the bracket with the exponent 3. And then right here, your base is 3 square, and then like this. So then when we simplify this, we just leave it as -2 cubed times 3 to the 6. All right. And then we cannot combine it any further because they are different base. Right? And then we just leave it like this. So those ones are pretty similar. Okay. Let's move on. Okay, let's do 7 on page 15. Okay. If the population of rabbit doubles every year, how many rabbits will there be in 3 years if there are currently 7? So there is a formula, or there is the generic way, like the logical way. Right? You could do the logical way or the formula way. Which way do you guys like more? Do you guys like formulas or do you like thinking logic? Yeah. Not during the lesson. Okay, so let's do the formula way first. So the formula is amount left equals amount initial, and then the rate, and then t to the n. Alright, so this is a generic formula for these type of questions where it like doubles every year, triples every year, half the previous years. These type of questions, this is like a generic formula for it. What all this means is like this is the amount at the end, so amount left or amount at the end. This is called A naught. All right. If those of you who are in science, what does A naught represent? What does A naught represent in science? A0. Anyone? Science? You guys haven't learned it in science? All right. So initial value. Okay. So this is called A naught or A0. It means initial value. This is the rate of change. This is the time in question. And n is how often it changes. Okay, so let's apply this formula. Initial value. How many rabbits were there initially? 7, right? Okay, what's the rate of change? Yep, 2, because it's double. So my R is 2. How long are we talking about in the question? How long are you trying to figure out? In 3 years. And how often does it change? Yeah, every year, right? Doubles every year, right? So 3 divided by 1. Okay. So 7 times 2 to the power of 3, basically. And if you calculate that on the calculator, 7 times 2 to the power of 3, you get 56. So your answer, what's my final answer? 56 what? Rabbits, right? All right. So you could use this formula, but if you think just in general, okay, so first off, there were 7 rabbits, and then it doubles every year for the next 3 years. So double, 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 and you'll get 56. Okay. So what if I said, what about in 20 years? All right. Can you guys tell me how many rabbits will there be in 20 years? How many rabbits is there? Yeah. Claire, what did you get? I got 7,345,000. Yep. So if this rate keeps going in 20 years, you're gonna have 7 million rabbits. All right. But we know that it won't get to 7 million because unfortunately some dies in those 20 years. So let's just say, very sadly, let's just say instead of rabbits doubling every year, half of its population dies every year. I'm sorry, sorry, rabbits. How would my formula change if I say half of the population dies every year? Which part of the formula will it change? Vincent? The 2. So instead of 2, it will be not negative. Eric? 0.5 or a half. Right. Okay. Yeah, so that's the generic formula, and we did it the logical way as well. You see that you get the same answer. Okay. Short lesson right here. So now that you guys know how to apply it with numbers, do you think you can apply it with variables? Yeah? Okay, let's apply it with variables. So let's first off recap our exponent rules. When you multiply two numbers with the same base, what do you do to the exponents? Vincent. Right. When you divide two numbers of the same base, what do you do to the exponents? Claire. And when you raise an exponent to another exponent, what do you do? Yeah. Multiply. Anything raised to the power of 0 is? Other than Vincent. Eric. 1. And negative exponent means what do you do to the base? Huh? A simpler word? No, so negative exponents. What does it make the answer negative? No. But what does it do? Negative exponents. Derek? Move the decimal place to the left. We're talking about exponents with exponents. Eric, what were you gonna say? Divide by what? Not divide by 10. But so let's say if your base was 4 to the negative 2, what happens to that base? Okay, I'll do it. Yes, flip the base. All right, so for example, like 2/3 to the negative 5. Flip the base to 3 over 2 to the positive 5. Oh, it should have said round. No, but your base could have been 4. So if it was like 4 to the negative 5, then you know it's 1 over 4 to the 5. Right? But the key is, remember, negative exponent doesn't make your answer negative. It just simply flips the base. Okay. So now let's apply it to variables instead of numbers. Okay, Kavishan, let's put that phone away. Thank you. James, for this one, what do you get then? What's my base here? Page 16. So what's my base? Okay, so my base is A. So instead of a number, it's A. And then what do I do to the exponent? 8, right? You add them. Okay, just like what we said right here. Okay, so Shakai, I know you weren't here yesterday, but let's try this one together. I'll lead you through. What's my base right here? So the base is the for both of these, it's b. And as we said, when you divide, you are subtracting the exponents. So 6 minus 2, 4. Yeah, so b to the power of 4. That's it. Okay. What about this one? Example 3 then. Yeah, Suhan? Yeah.
It's gonna be like it's gonna be negative 2 and then 12.
C to the power of 12. Right? Not negative, just the C. Okay, your base stays the same, and you're multiplying the exponents. Okay, d to the 0. Yeah, 1. Yeah, anything to the power of 0. 1. And then what about this one? E over f to the negative 2. Derek?
Over E square root square.
Yeah, that's it, with a positive 2. Okay, so you see it's the exact same rule as if it was numbers, but now instead of numbers, I used A, B, C, D, E, F. Okay. Let's try a little bit more complicated ones. These ones right here. Okay. When you have a coefficient in front, a number in front, you just multiply it. You just divide it as the same way. So the 2 times the 6 gives you the 12. And now I can combine the A's, my base. So what would this one be? Nick. It will be 12. Yeah, good. Okay. Now example 2. 30 over 27. It's not divisible, but I can reduce this fraction. What does it reduce down to? 30 over 27 is 10 over 9. Yeah. And what about the b's?
Each of them get like the 10. Wait, can you just b power 4?
Not 4. Oh, yeah, it is 4. Yeah, so just b power 4. Right? You can write it like this, or you can write it like this. It's the same thing. Right? You can write it either way. Okay. This is the tricky one. Example 3. Who has this one? Who wants to give it a try? Okay. Okay, very close. Remember, your exponent applies to everything inside the bracket. Just like if this was negative 2 times c to the 3. So Derek, well, how would it change?
Negative 2 to the 4 c to the 12.
Yeah, negative 2 to the power of 4, c to the power of 12. But what is negative 2 to the 4? Yeah, so you can just simply write 16c 12. Okay, so this is just to show you your exponent applies to the coefficient as well. A lot of people miss this. Okay, example 4. Negative 5d0. Yeah. Okay, Uvin says 1. Claire says she disagrees.
Oh, wait. What does this mean? Negative 5.
Yes. All right.
Brackets.
Right, there's no brackets. That's right. So this is negative 5 times d to the 0. I know it's 1. So then your answer is just negative 5. All right, so remember there's no brackets. So your exponent is only applying to the d. Okay, last two right here. Last two. Peter, what do you think? Yeah, example 5. Okay, a negative exponent. So what do I do to these? Flip it, yeah. So let's flip it first. 3f over 4e. What's my exponent now? 3f over 4e. Is it negative 2 or positive 2 now? Positive 2 because I flipped it. And now what? 3f squared gives you, what's 3 squared? Oh, that's it. 9. So 9f squared. And what about the bottom? 4e squared is? Yes, 16 what? E squared. Right? All right. Remember, your square applies to everything inside that bracket because there's brackets. So that's right. A lot of people write 3f squared. They keep forgetting to apply the exponent to the coefficient. Yeah. Because I dropped the brackets. So you're showing that you're applying the square to everything inside. Where?
4e 16 3x 9. Then why would you add another square? Then I would be like 80.
Oh, now there's no brackets. That square is only applying to the f, and that square is only applying to the e. Yes. Okay, final one right here. Final example. Genevieve, you want to lead us through this one? Which is? Good.
X squared times x. Did it like 2 plus 6?
Yep.
8.
Good.
And then for the y, it's minus 3 plus 2.
Yep.
And then e 6 plus 12.
Right, which is 7. Perfect. This z right here, there's no exponent. When there's no exponent, what is the exponent? 1. Right, so that's how she got the 7, the 6 plus the invisible 1 right here. But this negative 1, all right, this negative 1, remember it means to flip the base. So technically, if you rewrite this, it's 1 over y to the exponent 1. All right. And if I want to rewrite this much neater, much nicer, Jason, how would I rewrite this in a much nicer form?
Negative 8 x to the power 8 times x to the power 8. And
To the 7. Where does that y go?
oh yeah, it's like
And it goes to the denominator.
Yeah.
Right. Okay. Because if it's 1 over y, it's basically all this times 1. So it's on the numerator, and then denominator is just the y. Okay. So that is all. I did more than usual today. You can see my lesson is like 29 minutes today. That's because on Monday, I'm not here. I'm at the basketball tournament. So you'll get a supply teacher. I'll give you guys like some more practice worksheets. So your homework for tonight, because you have like a long weekend with the PA day tomorrow, is going to be from page 14 to 18. Well, we did a couple of pages in between. 14 to 18. Okay,